Greetings everyone. Welcome to the lecture on sample and sampling. The terms sample and sampling over here, as will be lectured on, is applied to research. In the field of research, the sole objective is to study a particular population. If it is social sciences research, we study attributes of population, and for this, the most um, appropriate way to find out some estimate or find out some result about a particular population is to take the entire population as a whole. However, many a times this is not feasible. So what we do is we take a portion of the entire population and label it as sample and try to make that sample as much as possible a true representative or um, a true representative of the particular population, that it is as much as possible exact to the entire population that we have in criteria for research. So what is the relationship between sample and population? We can understand here that the population is the universe. When I say, for example, that I want to check the stress level of college students, the entire college student population all over the world is my universe, that is my population. However, it is not practical that I can come up with results that I can generalize if I want to take each and every student's data here to to analyze the data. So what I do is I take a sample or a portion of the population which I consider and try the best through statistical techniques to make it a true representative of my entire universe, which is all the people who are college students in the world. So, by picture, if this is my population, then a portion of it is my sample. And I try to make this particular sample as much as possible representative of the entire population, that it becomes the voice of each and every participant that represent in this population. The need for a sample, starting with what we just stated, is first thing we sometimes cannot practically complete, uh, cannot practically administer any kind of intervention or a tool to come up with some research results on the entire population. It is not a practical solution most of the time, whole population coverage. Okay, so in this case, what is more feasible is to take a sample, um, calculate that or make sure that it is a good representative of the entire population and derive results from that. In that way, we save a lot of resources like time and other economic or financial resources as well. We save time because a population coverage the coverage itself or the data collection itself will take so much time that finally, when we conclude the results, many of the population would have progressed from the stage during which they were measured, and they might not be the people whose data will still be valid for analysis with the very recent ones, right? So, first thing, we save time. To do that, it might take us years, or probably it never will be possible. Because again, let's go back to the same example of college students, right? So if I start measuring college students from now onwards, covering the entire universe or covering the whole world's college going students population will take me years. Within those years, there will be new college students coming up, and the old college students will be passing out. They will be no longer college students, right? So we cannot hold what we measured true about the passed out college students um, 3 years ago. And the population that we are targeting will also be an infinite or um, never endingly increasing population because college students will keep on coming every year, right? So To save that time and to save other resources, we take a sample which we consider as a or which we make sure is a good representative of the population. We will see how to do that as well. Okay. Another thing, the moment we save resources and time, we get faster results. To calculate results from the entire population will take us a lot of time. However, if we rely on a particular representative sample, a good representative sample, the results can be generated faster. Plus, with the help of different statistical analysis or choosing the right method of collecting our sample, analyzing our data, we can attain reliable information from the sample itself. And that result or those results can be generalized to the entire population. There can be these two types of samples that we can come across, independent and dependent sample. For different types of study, different types of samples might be required. Both independent and dependent samples are important for different types of studies based on the objective of the study. Let's look at what they are. Independent samples are those where members from different sample groups do not relate to each other. That means these participants that you have cannot be shared or cannot be put together across groups. Or even if they are put together across groups, if they cannot be put together across groups, um, and even if there are different groups existing, the participants, there is not much care taken or there is not much requirement to make the participants very much similar to each other across groups. Okay? Across groups. Example, if my objective is to find the difference in well-being between male and female employees of an organization, the males are a separate category, demographically different, as well as culturally also. They will differ in terms of beliefs and attitude. The way culture will shape upbringing or the liberty and other things that are assigned based on gender. These are two different categories of sample. However, we're collecting data from both, and through statistical analysis, we are seeing if there is a significant difference between well-being levels or well-being scores of males and well-being scores of females. These are two samples that are independent of each other. They're different from each other. And the most important or the most highlighted difference that we can see here is the gender difference. However, a dependent sample, on the other hand, are those which have been divided into groups based on matched criteria. There are two ways of deriving dependent samples. One is, as given in the example, difference in well-being before and after meditation training among employees of an organization. These employees that we are talking about, the sample population we are talking about, can consist of both male and female. However, where it becomes dependent sample is that it is the same people for whom the test is done once before meditation, once after the meditation. So for participant 1, there will be a score before and there will be a score after the meditation. For participant 2, there will be a score before the meditation and there will be a score on well-being after the meditation. Likewise, we will have two sets of data before meditation and after meditation. What makes it dependent is that it is the data derived or it is the data extracted from the same population, same sample population. These are the same people, the same participants. Another way of designing the involvement of or the employment of dependent samples in research is when we are taking people and dividing them into two groups, but however, while assigning the second group, we match the participants of the second groups in some or the other criteria with the first group. For example, difference in well-being between uh, group 1 and group 2, who have been exposed to, one group has been exposed to meditation, another has been exposed to aerobics. Okay. Now, these two groups will be exposed to two different types of activities which are known to increase well-being. One is meditation. One group will be exposed to meditation. Another group will be exposed to aerobic exercises. The participant in these two groups will be matched at different levels. If participant 1 of meditation group is a person from urban settlement, then participant one or another participant in the group which is exposed to aerobic exercise should also be from urban settlement. Okay? We can make this criteria even more specific to try to have more homogeneity or more um, specific matches between them. So, likewise, each participant in the first group or in a particular first group which is exposed to one kind of intervention will have a matched pair or a matched partner in the other group. The match will be made on some or the other criteria that has been logically found to be relevant by the researcher. So they'll be matched on these criteria um, to participate as the sample population of the second group who will be exposed to a separate kind of treatment. The only difference here, to the extent possible, okay, apparent difference here would only be the two different intervention methods or treatment methods. Other than that, the participants are made as similar as possible to each other and they exist in pairs. That means each group will have equal number of participants. However, in independent samples, it is not necessary that both groups will always have exactly equal number of participants. There can be a few numbers up or down between the two groups. How do we choose the sample? The method we employ or the technique we employ to choose our samples are called the sampling techniques. Broadly, it can be categorized into probability and non-probability sampling. Methods used in or techniques used under probability sampling, techniques listed under probability sampling are more likely to give us a sample population which is normally distributed or whose data distribution matches the entire population's data distribution. To come to this concept, let me start by saying that if I collect data from an entire population and plot it on a graph, it is supposed to take a bell-shaped curve. It is supposed to data plotting should or is supposed to form a bell-shaped curve which has its average, its midpoint, and its most frequently occurring score, which we also know as mean, median, and mode, at the middle of the curve from the point where 50% data lies towards the negatively negative side of the curve and 50% of the data lies on the positive side of the curve towards the positive standard deviations. So, um, when we collect a sample population, we try to see that the sample population also takes a normal probability curve, which gives us an indication that yes, this sample population will match the entire population. So, probability sampling techniques have the capacity, have the ability to give us a sample that is very much alike to the populations, the entire population's data distribution. Non-probability sampling techniques has, in comparison to probability sampling techniques, non-probability sampling techniques have lesser ability to give us a normally distributed data. However, if the sample size is large, it can still help us attain the criteria for a normally distributed data. Apart from the aim of whether we want a normally distributed data or a data which is not normally distributed, okay, there are also other reasons why we select one or the other sampling techniques. For example, one of the reason can be the type of population we are targeting. If the population is someone who is very hard to reach to, or it is very hard to set a criteria of selecting them, then it will be more important or it will be more appropriate for us to use a non-probability technique where we have the possibility of reaching out this difficult population through one of the techniques, for example, like say snowball, where we contact people by starting with one reference point, one person, one participant. That person refers us to two more people. Those two people refers us to four more people and more, etc. Or probably If the criteria of the population cannot be set very clearly due to probability of lack of research in that area, or possibly the population is not very easily available, we can also go for purposive sampling, where we have a very strict criteria, well set criteria, and we only take those who match that particular rationalized criteria. Okay, so that is also another reason, apart from the aim to get a particular type of distribution, normal distribution, normal distributed data, or the possibility of considering that I might get not normally distributed data. Apart from these kind of aims, there are also other things that helps us decide which sampling technique we should take. One example we just said, which is depending upon what population we are targeting. Anyways, let's go ahead and understand about what are these probability sampling techniques and the non-probability sampling techniques. The first probability sampling technique mentioned here is the simple random sampling. So simple random sampling employs randomly selecting cases from a particular population to be selected to our sample as our sample participants. Now, this simple random sampling would require us to consider that every person in that population, or every member of a particular population, has equal rights to get selected as our sample participant. Okay, we can do that. We can do simple random sampling by first giving a number to all the people in that population, and then finally generating who will get selected into our sample population by a random number generator. Or one way of understanding random number generator is, let's say, chit pulling. Okay, we have a box of chits. Each chit has a number written against it. That number denotes the participants, and we randomly pull chit. Now, this is a manual way of how to understand simple random sampling, but there are random number generator systems as well, which can help us better in understanding which people we can take. So, pertaining to the idea that all people in that particular population has equal chances of getting selected, to be unbiased, we randomly select uh, which participant will be included in my study or in our study. Now, the next sampling technique that we are going to talk about is the systematic random sampling. In systematic random sampling, again, like in simple random sampling, we assign a number to all the people in the population, and then systematically select a particular patterned population to be included in our sample population. For example, I select every even number person. So everyone who is getting a number like 2, 4, 6, 8, 10, etc. are going to be the people who will be included into my list of participants for the research in my population sample. Stratified random sampling is when we divide the entire population into different stratas or different um, categories, and from each category we take the we take a particular number of sample. For cluster sampling, we choose cluster sampling as a method when, let's say, certain populations are very hard to reach. Let's say we want to do a study on all the um, Reliance offices, Reliance offices that are across India. Now we cannot reach out to all offices in India. We choose any three which are located in one particular city, let's say one particular state, let's say in Karnataka. Okay, so three offices that are stated in Karnataka. Our cluster is set that these are our three clusters from which we are going to take the sample. And we take data from all the people that are present in that but in these three organizations. All the people means people who meet our criteria. For example, we want to take people who are in the management, so we take data from all the people who are working in the management in these three offices. Okay, in these three Reliance telephone offices. Moving on to non-probability sampling. Convenience sampling is when we are selecting our participants, or when we are including our participant based on how convenient it is for us to reach. I want to do a study on college students. So whichever college I'm finding nearby to me and students are available, I'm going and telling them that please fill up my form. We are not employing any numbers to them. We are not employing any randomization in selecting them. Purposive sampling, uh, sometimes also called judgmental sampling, is when we are selecting our participants based on a preset criteria for our research, for which we have a good logic or good rationale of why this criteria should exist, and we select people who matches this criteria only. Now let's say I want to do a study on female students who have been or who have struggled to get through college due to cultural pressures. Now, out of all the female students who might be there in a particular college that we want to take as participants or that could qualify as participants, we go ahead and judge their eligibility based on different criteria of struggles that we have listed for our study. Now, everyone will face struggle, someone financially, someone culturally, someone from family, someone from their own personal factors like a health issue or a mental health issue, right? Now, when we say female students who have faced barriers due to cultural reasons, we specify it further what kind of cultural reasons. Okay, so likewise, we set a particular criteria for who will be my research participants, and now it will be hard for us to openly judge who will be these people, right? So we observe, we study, we take some parameters before, and then after that, if we are uh, being able to as experienced researchers we are being able to understand that yes, this participant does meet the criteria that is required for my study, I go ahead and take that participant as my sample. Purposive sampling is something that is very much applicable in qualitative research. If it is quantitative research, we try to use purposive sampling in rare cases where the population that we are targeting might not be very readily and easily available, and we have to go with certain criteria that we have chosen based on rationales. Snowball sampling, which I have already talked about, is when we are reaching our participants from an initial few reference points to a larger group of referred people. Quota sampling is when we decide on a preset criteria before uh, investigating much about the populations or our requirement for a particular number of people to make it a representative sample. Like we did in stratified random sampling or clustered sampling, we take up certain quotas, certain categories from which people have to be selected. And we have a preset number as well that per criteria we will select only 100 people or we will select only 200 people until and unless we reach that particular set criteria or number of data for that particular quota or for that particular category. We keep on collecting data. However, this keeping on collecting data is not following any of the probability methods of collecting data. Rather, it will go ahead, for example, including based on convenience or snowball, etc. But we are collecting it based on the different criteria that we have, which are also denoted here as the quota. So I hope this has made the idea of sampling techniques clear to you. Now, when we are employing so many sampling techniques, we try to take utmost care so that the sample population that we have is a representative one. However, there can be chances of biasness, and that might lead to sampling errors. Sampling errors indicate that the sample that we have selected is not a good representative of the entire population, which means that the sample population's parameters, the descriptives like mean or median, will be different from the population mean or median, etc. In that case, whatever results we are deriving from the sample might not be something that is appropriate to be generalized to the whole population. So let's say what kind of biasness in sampling we may reach. There are three mentioned here: selection bias, sampling bias, and observation bias. Selection bias is a systematic error. It is an error in choosing the appropriate sampling technique, probably an error made in the methodology or an error made in the estimation of population proportion, like what proportion of the population share certain characteristics, or basically it's more about, we do not have much idea about that population and how to select them. So we also end up selecting a wrong sampling technique. In that case, the sample population that we get will not be somewhat very representative of the entire population. Sampling bias is the biasness in selection of participants. If we survived the selection bias and we employ a particular sampling method which is considered as appropriate, which has been successfully defended as appropriate, there is still a chance that there might be sampling bias. In a particular population, certain participants always tend to have more chances of getting selected. For example, people who are voluntarily very much agree to be a participant. Now, these voluntary people are willing to participate, and based on the will, their responses might be something that is different from those who are not willing to participate. However, these voluntary participants' responses might not be similar or might not speak the truth about those who volunteered not to participate. Okay, there can be other reasons also for a particular group of participants in a sample population or in a population to be more in favor of getting selected. So when this happens, and we as researchers fail to observe that and take care of that, we might end up committing a sampling bias. Observation bias is when we collect data, the reading of the data that we are making or the recording of the data we are making has been has gotten manipulated because of our own biasness in thought or because of our own biasness in expecting a particular result. That is a observation bias. So observation bias is something related to sampling bias rather than directly calling it as a sampling bias. However, these are three biases that are uh, indicating sampling biasness or are heavily related to sampling biasness. If there is sampling biasness in one way or the other form, then we may end up having a sampling error, which is deviation of the sample mean, which is an important parameter of a particular data set to process it further or even to describe it. Okay, we may end up getting a sample mean that is very much deviated or very much different from the population mean. Sources of sampling error might be um, in not properly estimating the population. That means we do not have much knowledge about the population, much knowledge about the characteristics shared by each person in that population, etc. Randomness, even though it is something that we employ as a probability sampling technique, randomness sometimes can also give us a sampling error if our sample is very small. That means a less sample or a small number of sample plus randomness is an indicator of having a sampling error. Inaccurate sampling method, which we already talked about as the selection bias, and biasness in choosing sample, which is the sampling bias, can also be sources for sampling error. One way of avoiding sampling error is to have a large population. In terms of quantitative research, it is better to have a large population which can help us avoid many of these sampling errors. So that was all about sampling techniques, sampling biasness, and sampling error. I hope this video will help you in understanding the importance of sampling and how we can help ourselves get a more representative sample of the population. Thank you so much for listening and being patient.